All right, so what we're going to do is we're going to take the imaging plate out of the cassette and we're going to put it into the gadolinium cassette.
You ready?
I'm ready. And we have to do that with the lights out in a darkroom condition so we don't expose the imaging plate.
Will you facing me?
There's me, blue side down. All right, and now we secure that inside the cassette, and then we can turn the lights back on. Okay. So we set the gadolinium cassette up in front of the beam. And then we put the sample piece that we're imaging up against the plate, centered with the beam. And then we're ready for exposure. We're set up in the beam cave. The beam cave door is closed, and we would like 50 kilowatts at the D2O tank.
Understood. 50 kilowatts at the D2O tank.
Thank you. And we'll do the timed exposure down here. All right, so we're going to do a timed exposure for 30 seconds. Opening shutter. You have a timer ready, Allison, a secondary timer. Shutter's open. Shutter's closing. Sean, you can shut down and move away.
All right, understood. Thank you.
Reactor operating 100 kilowatts and zinc shutdown.
Okay, and we'll take it to the CRX Flex. So what we've done so far, we've operated the reactor at 100 kilowatts, coupled to our D2O tank. The neutrons escaping the face of the core are fast neutrons. They interact with the D2O to thermalize the neutrons. It slows them down. And then they travel down the length of our beam port through our bismuth crystal. And then they interact with the material, in this case the patch. As they pass through the material, they then pass through our imaging plate and interact with the gadolinium plate. The energy that's then released from the gadolinium plate exposes the imaging plate to give us the image. So we've come up to the digital device, the CRX Flex, and we're about to acquire that image. Yeah, I think we're overexposed because previously we're really able to see these areas
Yeah,
of contrast.
we're not.
Where there's
Look
like
how white these are.
there's like some calcium built up here and stuff like that that really showed up much clearer previously.
I don't even see the coral. I see very tiny little patches of coral, and the coral should be crystal clear.
Yeah.
So I think we're over.
Thing is, so the areas where the rivet pattern is, we should be able to see those. And since we're overexposed, then
Yeah.
that's why we can't see those. So,
Yep.
yeah. So maybe this was 30 seconds. So maybe we just
15 seconds at 100 kilowatts, or do you want to go back to old tried and true and then compare the two and then decide from there?
Yeah, I think it's what we should do.
Okay. So we'll do the 15 at 50.
Yep.
See where we land in the middle of that,
Mm-hmm.
and then make a smarter decision.
Yep. That works.